barakatuh. Welcome.
A good day, doctor.
Good day. How are you?
Um, Alhamdulillah, I'm good. I have maybe 2 to 3 questions, one which is related to this class and two are not related to this class.
It's okay. You're
Um,
welcome.
so as the one related to this class, I think Wake by default give us the result of the testing set. So I think we need not worry much about the underfitting problem since the result that we'll get are the testing set results. And then secondly, it's about the ANN multi-layer perceptron. So I think by default, Waker will say the hidden layers is A. So I just wanted to clarify what does that A mean.
Sorry,
And then
your voice is a little bit, maybe is it far away from the source?
okay, am I now audible?
Yeah, I think it's better now. Can you come again with the second question?
Okay, so I said in Waker, ANN gives the default number of hidden layers as A. So I just wanted to clarify what does that A means. For me, I think it's 1, but I just wanted to clarify from you.
Okay.
And then lastly, I had a data that I used ANN and random forest algorithm. So I did a simple Google search, and for the random forest, I found that it has not much hyperparameters. I think I just found the number of trees and maximum depth. So I just wanted to confirm from you if there are some hyperparameters that you are aware of for the random forest algorithm.
Okay. Okay, thank you very much for the question. So, yeah, as for the first question, you said, yeah, well, if you are using Weka, so by default, Weka, we show you the testing result. I think we've discussed this in our earlier videos, I think, where we discussed how we can try to enable your Weka to show to you the training set outputs.
Yes.
Yeah.
Yes, I'm aware. We just need to check the output model for training set.
Exactly. So, however, by default, the Weka will only show you the testing set. So if you are not getting it, then you know that, oh, then sometime we say, okay, why am I not getting it? Is it underfitting or overfitting? This is why you need to know, you need to see the result of input of the training set before you can know that the problem I'm facing is underfitting or overfitting. You know, so when you see only the outputs, only the training outputs, the training set performance, maybe it's like 50%. Is it underfitting or overfitting? So as the case may be. So in that case, you can enable that, okay, Weka, please let me see the result of training set. You can be able to say, okay, this is either underfitting or overfitting, or as the case may be. But the good news is that if you can do more of the hyperparameters to check, change your model, change the algorithm you are trying to use, that will actually show some of the clue on how to solve the problem, or as the case may be. Regarding the question of hidden layer in neural network, yeah, the default value that are there, but we can always change our default value as to any value we want it to be. Yeah. So usually every algorithm will have a particular default value depending on the platform you are using it from. You see, are you using Weka? Are you using Orange? Are you using the Python and host of other platforms that are, or MATLAB that are available? Some of them will come with the default value, but you're always given the opportunity to change those default value to whatever value that you want it to be. As for the hyperparameter for random forest, random forest is one of the very popular ensemble techniques. So which we discussed earlier, that is the ensemble techniques. Random forest, as the case, you remember decision tree. Decision tree is a very simple way, very common. So whereby you look at it, you divide into 2 here. At this point, you divide into 2. You keep going until every node is a terminal node that the decision has been taken. So the random forest is when you try now to make an ensemble. Ensemble is trying to combine multiple classifier into one. So it's like taking decision by consensus of multiple experts. So you train many decision trees. So when you have many trees, we say a tree make a forest. A tree make a forest. That is where the name random forest come from. Random forest. When you hear random forest, it means they combine several decision tree to produce forest. So this is where the terminology comes from. Then the random means, you see, because there are other ensemble methods of decision tree that does not follow the random pattern. Random means, when you use decision tree, in selecting the next, at this point, we select the attributes to be used to partition our data. We can refer to our earlier videos on decision tree on how this works. We have a couple of videos on that in our archive. You can check it out for those who might be hearing it for the first time. We take decision here. Okay, maybe we have 3 parameters. We have the weight, we have the weight, we have the age, and we have the salary to predict somebody should be given a loan or not. So when we select, let's say we select age for partitioning, before we select that age, we need to run what we call the information gain. Information gain. That information gain, we check which of these attributes will quickly give us better result. You see? So based on that information gain, we start with the one with the better information gain. The next one might be weight or might be salary. So we don't just select the one to be used for partitioning at random. However, in the random forest, we do it randomly. This is where the random comes from into the name. So when you are not going to select how to partition at each of this junction here, you are going to have at each of this node, the partitioning takes place randomly. You can choose age here, you can use weight. Another decision tree can start with age, another one can start with weight, another one can start with salary. You do it at random. This is where, and then all of them will produce decision tree, but with different starting attributes at different nodes. So this is where the name random comes from. So for the random forest, so since you are not doing information gain, it makes it a little bit very simple. So the stuff are going to be run at random to be able to generate several trees, which indicate and then form the forest. So majorly, you see people talk about the number of depth you want your tree to go, because sometimes you can allow the tree to go so deep, then you have to prune it out, especially if you are doing only decision tree. But when you want to use it in an ensemble, then people recommend that it's good for you to set a kind of depth that the tree should stay before actually it stop the training. So random forest is not one of those with many attributes, as the case may be. Just like you just mentioned, it has very few hyperparameters. And like I said, once you load it, if you are using Weka, once you load it in Weka, you see where you have the name indicated, they will indicate those hyperparameters that you need to change, you need to check, or as the case may be. Other parameters are just ordinary parameters. There are many there, but they are not necessary for you to touch them. Some of them are just default, like telling you decimal places. How many decimal places you want the answer to be? It should be in 2 decimal places or not. These are not necessary issue, and that is where, again, when we differentiate between hyperparameter and parameters. Everything, all of them are called parameter, but hyper they are those parameters that have direct effect on the performance of your algorithms. So I hope that answered your question.
Yes, doctor. Thank you very much.
Thank you very much also. Barakallahu Feek. So any other question? Okay, so very timely. So
okay,
yeah.
If there's I have one more question. There is one popular algorithm which is called the Anfis. I don't know if it's, I searched Wiki, I couldn't find it, but I don't know if it's there maybe with another name or something like that.
Anfis, eh?
Yeah, Anfis, yeah.
Okay. Yeah, Anfis is a, just a minute. This is my writing pen. It's one of the area that one of these I hope we have the opportunity to discuss it in the AMFIS. I think this is what you are referring to. Am I right?
Yes, it's the one artificial.
Yeah. So it's a neurofuzzy system. So one of these days, I hope we have the opportunity to discuss what we mean by fuzzy system. See, fuzzy logic led to what we call neurofuzzy. When we combine neural network with fuzzy logic, we generate what we call NF, neurofuzzy. AMFIS is one of the method under the neurofuzzy, one of the model under neurofuzzy. You can, I've not used this. I used to use AMFIS in MATLAB before. I've not tried it on Weka, but I think it should be there. So try to go to add a package in Weka. I think AMFIS is supposed to be in Weka. It's been a long time that's been in the market. So it's a kind of modeling system that is based on fuzzy logic. And fuzzy logic on its own is a total change of paradigms in the way we do computing, because our present computing system is based on the idea of yes or no, 1 or 0, yes or no. But we find out that in reality, if we want to take computer to closer to human mode of reasoning, human beings don't reason like yes or no. We reason there are a lot of gray scale between yes and no. Between 0 and 1, I'm not yes, I'm not no, but I'm in between them. You see, probably if you say what is the temperature, temperatures cannot just be 33 or 0. In between them, that's between this and this. But the present computing system is based on what we call crisp logic. Crisp logic, yes or no. But in reality, human beings like to process idea using fuzzy terms. The temperature is high. When I say the temperature is high, I'm not telling you a particular temperature. You figure it out. What is high in your own community might not be high in my own community. That is called fuzzy thinking. You see, it's one of the concepts in AI that actually shifted the paradigms when it comes to computing. And it has been used to solve a lot of real-life problems, especially in machine learning. If you can carefully integrate fuzzy logic to your data, especially if your data is noisy, fuzzy logic might be able to render your data better than ordinary method, as the case may be. So, like I said, it's one of the methods we have opportunity to discuss this in future in one of our engagement, inshallah. So you can check out in the Weka. I want to believe that it should be possible to have AMFIS in Weka. Go to package addition for a function. I think we also demonstrated it earlier. So we can check the video on how to do that and then try to add it. I think AMFIS should be there. I want to believe that.
Okay, inshallah, I will check.
Okay.
I will check.
I wish you all
Thank
the
you
best, Brother Ismail. To Barakallahu Fik. So this is what we're going to have it for the day. So thank you all for listening. So inshallah, so till another time. Thank you very much. Assalamu alaikum.